So remember, first thing you have to decide which one is invisible, which one is visible, because we can exclude the one with invisible solution. So when M1 equals to 0, so the weight for item number 1, okay, the weight is 2. Okay, so that means 2 times 0 is 0. So in this case, no problem. We can have all the solution because 0 is less than 0 until 4. Now, when M1 equals to 1, okay, so if we try to find the combination, it will be 2 times 1, which is equals to 2. So 2 here, so if you compare to all this total weight for this x2, so only for this part, okay, when x1 equals to 2, x1 equals to 3, and x1 equals to 4. Okay, in order to follow this constraint. Then, when M1 equals to 2, it will be 2 times 2. Okay, 2 for the weight, for weight per unit of item 1, and 2 for this one. Okay, M1 equals to 2. So 2 times 2 is 4. So in this case, if you can see that 0, 1, 2, and 3, all these are less than 4. Okay, so for only this one is available. Okay, when x1 equals to 4. So in this case, we can exclude all this solution because they are invisible. Now, using this equation, find the values of all these visible solution. So for example here, when x1 equals to 4, maybe it's not clear here. When x1 equals to 4, okay, so 31 times 0, m1 equals to 0, plus f2, okay, x1 equals to 4, 2 times 0. So it will be 0 plus f2 of, okay, 4 minus 0 is 4. So if we refer back to our previous stage, okay, so f2 of 4 equals to 61. Okay, this is f2 of 4 equals to 61. So that's why here will be 0 plus 61 equals to 61. I just copied the value here, okay, because this is not clear. Okay. Okay, now, okay, so you have to do this for all these feasible solution, and then at the end, okay, for this optimal solution, you have to look at one by one, okay, for the x1. So when x1 equals to 0, okay, you have the option, okay, the value is 0, and it comes from 0, okay, when m1 equals to 0. Now, when x1 equals to 1, okay, again, you have no option, 14 is the answer, and 14 comes from 0, okay, m1 equals to 0. Then, when x1 equals to 2, you have to compare between 28 and 31. And since we want to maximize our return, so choose the maximum value. So we choose 31, and this 31 comes from m equals to 1. Then, for x1 equals to 3, you have to compare between 47 and 45. So the maximum is 47, and this 47 comes from m1 equals to 0. And finally, the last one, when x1 equals to 4, you have to compare between 61, 59, and 62. So the highest is 62, okay, 62 here, and it comes from 2, okay, when m1 equals to 2. So now we have finished all the 3 stages, okay. So what does it mean? So at stage 1, you can see here, okay, all these are the list of these optimal solution. And remember, our aim is to find the maximum value. So in this case, 62 is the highest, okay, and the value of m equals to 1. That means for item number 1, we take 2 units. Then we go, before we proceed to the previous stage, so we can calculate the value of x2 here. Okay, x2 equals to x1 minus 2m1. So x1 is 4. So 4 minus 2 times, just now m1 is 2. So 2 times 2. So we have 4 times 4 minus 4 is 0. So now x2 will be 0. Then we will use this result. Okay, x2 equals to 0. Go back to our second stage. When x2 equals to 0, m2 equals to 0. Then we can use this equation. So now we know that for x3, it will be x2 minus 3 minus m2. So x2 now is 0 minus 3 of m2. m2 is 0. So x3 will be 0. And we will use this solution for the previous or stage 3 solution. So at stage 3, when x3 equals to 0, m3 is also 0. Now, the conclusion that we can make here is that for stage 3 or item 3, okay, m3 equals to 0, means there's no unit of item 3. Then for item 2, again, m2 equals to 0, so no unit for item 2. And at stage 1 or item number 1, so we have m1 equals to 2. Means that 2 unit of item 1. And the return is 62. Or in this example, because the value that they use, that they are given is in thousands of dollars, so that means the total return is 62,000.